All right, let's resume here. All right, and so now we're going to cover the package Applier, which again, incredibly useful. This is just kind of an intro tutorial on using Applier. I think you're going to get better at using Applier by actually using it. Okay, so just like anything else, when you just watch me do things on the screen, or if you just follow commands exactly yourself, it's not going to be, it's not the best, but I'll try to make some useful problems in your homework. So this week, I've already put up homework 2. Okay, let me just talk about homework 2. So I've already put homework 2 up, and it's all kind of like programming functions, and so you can get started on that. Some of these are a little bit, they're intended to be a little bit of a challenge in terms of thinking about how you're going to program your functions. Okay, and the first 4 functions that you program, I've asked for you to just use the basic kind of assignment and arithmetic operators and comparison and logic things. So don't use any built-in functions. Don't use there is like a modulo operator. Don't use that, okay? When I ask you to create a modulo function. So anyway, so that's homework 2. I'll work on another homework that involves using Applier, and that you'll see that soon. Okay, but anyway, Applier. These are probably the 6 primary quote verbs that exist in Applier. And these are the verbs that we will use, that we're going to apply them to our data, and it will handle things. Okay. All right, and so if you haven't done so already, load up New York City flights. Okay, 20. Okay, and then so we'll do NYC flights 2013, or I'm sorry, NYC flights 13. Did I already load this library? Okay, and then we can take a look at like some of the flights data. Okay, we can ask about flights, and if I load up flights, it's got 336,000 rows over and 19 columns. Okay, and so it's already in table form, and so we only see just a few of the variables, and we can see other variables that are not shown. Tail number, which is related to like what actual airplane, the physical airplane it is. Okay, the origin, destination, all of this kind of stuff. Okay, and so this is just a whole bunch of flight information. And Applier, we can throw this at Applier, and it will use it. Okay, so we have select to extract certain variables, and then we have extract for getting the observations. Like, I'm sorry, not extract, filter. Okay, so select is to choose your variables. Filter is to choose which observations you want. Okay, so this is assuming everything is in tidy data, which is how we want our data stored. 1 column per variable, 1 row per observation, and select and filter is useful for that. Okay, mutate will create new variables from existing ones, and then summarize. This is a key one. Will change the unit of analysis. Okay, and so what we mean by that is, instead of trying to look at each individual flight, summarize will group flights together. Well, not group flights together. It'll work to the next level of things. So if we just use summarize on the data now, it's going to summarize all 330 or 770, or however many thousand observations into a single line. Okay, so basically it's just creating a summary, one summary line here. Okay. All right, so let's take a look at. Here's select, and it's using it on the storms data, but we could do storms with flights. I can just do flights, and then the pipe operator, and I can do select, and then what we want to select is let's say we want to do select departure time, okay, and departure delay or something like that, okay. And here now it says, you know, I still have 336,000 rows, but I only have 2 columns now, okay. Now this, with the pipe operator, okay, the above command with the pipe operator is the same as using select and then feeding in flights right here, and then something like that, okay. There are a few cool things you can do with select under I'm getting tongue-tied here. With select, can you guys see this? How do I magnify this? Okay, I don't know how to. All right, there's a few ways you can do starts underscore with, ends underscore with, contains, or matches, or things like that. Okay. So, you know, if we ask for structure of flights, okay, we can see a bunch of these things, and then so when we use the command flights, okay, and I'm going to feed it into select, I can say, you know, starts underscore with, oops, let's say starts with ARR for arrival, okay, and it's going to pick the variables that start with arrival. Or I can do ends with time, and it will pick the variables that end with time. So departure time, scheduled departure time, arrival time, scheduled arrival time, and air time, and things like that. Okay, and so there are a few nice little things that you can use with select. Okay, so you can select. So here's, you know, just simply when we apply it to storms, we can select the column storm and pressure. We can select everything other than storm by putting a minus in front of it. You can use a colon in kind of the same way that we say, like, numbers 2 through 10, 2:10, we can say select the columns wind through date by using the column. So I can do, if I go back to the structure flights, I can say flights, feed that in to select, and select, we want, let's say day through I don't know, destination, something like that, okay? And it will schedule, just select the columns from day through destination and things like that using the colon there. Okay. Yes, other useful select functions. Okay, yeah. So ends with, starts with, one of, or things like that. Okay. So you have all of these other things. Again, all of these you can look at kind of the help function for select, and it gives you some examples of how things will work. So we use select to choose our columns, and filter will choose the rows for us. Okay. So here we are filtering just so that we have wind to be greater than or equal to 50. Okay, so it's just out of the storms here, it's just choosing the rows where the column wind is greater than 50. Okay, now we could do this ourselves using you know, some kind of subset procedure, which you know, you're supposed to read about. But using filter is just another way to subset our data quite easily. So filter will choose our observations. Okay, you can combine subsets or conditions. Okay, just with the comma here. Okay, so for example, if we're going to look at the flights, maybe I want only, we're going to take flights, and I want to just filter it so the carrier is United Airlines, okay? And maybe we also just want for the month equal to 4, okay? And so this one will have all, I'm just putting, condition after one condition after another, and here I'm specifying carrier has to be United Airlines, month has to be equal to 4. I can even further do this and say departure time is greater than, I don't know, 900, and departure time is less than 1,000 or something like that, okay? And so this will choose only the flights that depart between 9 and 10 o'clock here, okay? And so all you have to do is just add one filter right after another, separated by commas here, okay? And there's those are just certain comparison ones, and so this is how you can filter your data in R using filter, okay? And so we can see, we still have all of the columns, but here just now 295 rows. Okay, so far so good. All right, and mutate basically will take columns of data and you can create a new one based on the existing data here, okay? And so let's say I wanted to do well, we already have a column for departure delay, but we can create a new column. So here, what I'm going to do is I'm going to take flights, and I'm going to select just ends with, we'll just take the time-based columns, okay? And then from there, I'm going to filter, we'll do ends with time, and we also want carrier, okay? And then we'll set carrier equal to UA, okay? And then from here, we'll create a mutate, all right? So there is a departure delay column already, but I filtered that. I mean, when I did the select command, that no longer exists, right? So I can create a new column called departure delay, or we'll just say, yeah. So I'm going to do mutate. We're going to take this data, and we're going to create a new column called departure delay, and I'm not going to have an underscore here to kind of distinguish it from the others. And then what we're going to do is we're going to take departure underscore time and subtract off scheduled departure time, okay? And so we can see the difference between departure time and scheduled departure time, okay? And this creates some problems here because it just sees this as integer variables, right? So 600 minus 558 is a difference of 42, but we know that in the clock it's actually only a 2-minute delay, but here it says you were 42 minutes fast or something like that, okay? So we obviously have some problems here, but you can see how the command mutate creates a new column based on the existing columns here. So you can create things that way, okay? And they're all they're vectorized so that it's basically going to just take the value that's in the departure time column, the value in the scheduled departure time column, and it's going to create a new value. So you're going to get one new value for every single observation, okay? And we call that we call these types of functions. Okay, so here's more. We call these window functions because basically each value will produce another value here, okay? And then we have some of these which are like cumulative mean and cumulative min, max, and things like that. Okay. So cumulative sum, okay, is it's going to take the first one 1, and then when he takes a 2, it's going to add that to it and get a 3. When you take a 3, it's going to add that to it and get a 6, and so on and so forth. And so you get whatever this sequence of numbers is. All right. Okay, so that's mutate. All right. Summarize. What does summarize do? What summarize does is it takes all of your variables or all of your observations and just summarizes it down to 1. Okay. So so in this case, we have when we're looking at the pollution data set, we're going to create summarize. And what we're asking is we're asking for the median of the column amount and the variance of the column amount. Okay, and then over here, this is the name that we're going to apply to it. Okay, so this could just be gibberish. So, but here, we should give it some meaningful names. So we're going to take pollution, which looks like this, and we're going to feed pollution into. Okay, feed pollution into summarize. Now this is Hadley Wickham is from New Zealand, so he spells things the other way. And so if we want to summarize, let's say we want the mean of amount. Okay, we can give it a name. Okay, now I can just call this whatever we want to call it. Okay, and it's gonna just create that thing. Okay, so it probably makes sense to call it mean. All right, and then we can create something called median, where that's going to be equal to the median of the values in the column amount. Okay, so we have the median and the variance. And then you have other ones like n, which will give you a count. And you don't have to feed anything into that. Okay, and then so here is a bunch of other functions that can be used inside the command summary. Okay, min, max, mean, median, sum, variance, standard deviation, all of these things. Okay, so these ones, the blue ones, you need to have dplyr loaded. Okay. Okay, so again, summary, it takes all of the values and it summarizes it into one single value. Okay. All right, arrange is like sorting. Okay, so with sorting, we can sort on wind. Okay, and if you want to have, so here it's he color coded these, and so after we sorted by wind speed, we can see how it arranges it from least to greatest. Okay, so when we sort on wind, we have that. You can give it, you can do descending on wind for arrange. Okay, and you can also give it first arrange on wind, and then to break ties, arrange it on this next thing. So in this case, we're going to arrange on wind, and then we're going to arrange on date. And we can see that if we didn't have the date thing, we've got Anna, Alex, and Arthur, okay, going like this, but we have 1998 coming before 96. So if we want to say, okay, arrange on wind and then date, we can see that those things switch. Okay, so it says, arrange first on wind and then arrange on date. Okay, so I think when you guys first get started with R, there's a temptation to open up your data sets in Excel or something, and then do a lot of these things where you're going to be sorting and filtering and summarizing data in Excel. And I want to discourage that. Okay, Excel is very useful for certain things, but then for other things, I would say R is much better suited. And once you have dplyr and you get the kind of this quote slate of verbs mastered, then there's really no reason to go into Excel to do some of this basic data manipulation. Okay. Now, obviously, if you have just a tiny little CSV, or if you need to do some data entry and things like that, then Excel is suited for that. Okay, I still use Excel for, you know, handling grades and things like that. Okay, because it's well suited for things like that. But then if you're gonna try to do calculations and stuff like that, I think RStudio is far superior. Okay, and this replicates a lot of the kind of the sort functionality that exists in other programs. So that's you've got arrange here. Okay, pipe operators, so we can just kind of feed things. So here's an example where we're going to start off with storm, and then we're going to use select on the storms to just select columns. Once we select that, we can pipe it in. Okay, so we're just rewriting things in the pipe form. So here we're starting off with storms. We're going to pipe it into filter, and we're going to take that output and pipe that into select. Okay, so we can see how we've filtered just the storms with wind speed over 50, and then after that we are selecting just the columns here. All right, so what will happen here if I do this? We're going to take storms, and it's going to create, what does mutate do? Creates a new column ratio, okay, and then the result of that, we're going to take that and just select the column storm and the ratio. So it just creates this resulting thing. We just have the storm and the ratio. Again, Control-Shift-M for the pipe shortcut. Okay, unit of analysis. This is where I think dplyr really shines to make your lives so much better. Okay, and maybe that's a slight exaggeration here, but as far as data analysis goes, okay, when we apply the function summarize, it's going to take all of this and reduce it down to one row of data here. Okay, now we can apply something and let R know a little bit about the structure of the data inside this table, so that when it summarizes it, rather than summarizing all 6 values into one row, we can say, hey, you know what? We have 3 different cities in here, and I want you to summarize on the 3 different cities. Okay, and so what we're going to do here is we use the command group by. Okay, so we say inside here, group the data by city. Okay, and what that does, it says, okay, we've got New York, we've got London, we've got Beijing. Okay, and then if we apply, so group by all by itself, it doesn't seem like it does anything. Okay, but then when you combine group by with summarize, then you get this extra power, where now rather than summarizing all 6 units into one row, it's going to create 3 separate summary rows. It's going to say, okay, I've grouped these rows of data, and I'm going to summarize that. I'm going to group these rows of data, and I'm going to summarize that. I'm going to group these rows of data, and I'm going to summarize that. Okay, so basically you're going to do this, you take your data, you apply the group by function, and then you apply summarize to it. Okay, so here we'll just, if I do pollution, so pollution looks like this, and then if I take pollution and then and I say, okay, group by city, it looks exactly the same. It doesn't look like anything changed, except there is one little change, and it says groups, we've got city, and there's 3 of them. Okay, okay, and then so again, when you look at it, it doesn't look like anything has happened, but R knows that there are now groups inside this data. Okay, and then so now we can run the function summarize. Okay, so let me just start off by running summarize just on pollution itself. Okay, so I'm going to do pollution summarize, and the summaries we want the mean, the sum, and the count. Okay, so we're going to do mean for mean is equal to mean amount. The sum will be equal to the sum of amount, and n will be n. Okay, and so it takes all 6 rows and it sums it up into just one here. Okay. First, now I'm going to do I'm going to do this group by first, and then once we have pollution grouped and I feed that into summarize, now it says, okay, I've grouped it by city, and these are the results here. Okay. If you didn't have dplyr, this would be a lot more work. Okay. If you didn't have dplyr, you would have to subset by each city, and then you'd probably have to I wouldn't even, I've completely forgotten how we had to do this without dplyr. I think you had to subset them first, and then you would apply a kind of a summarizing function, and then you'd have to stitch them back together. Okay, and so it's this has greatly streamlined our ability to summarize grouped data here. Okay, because before we used to have to slice up our data into different chunks, and then we would apply the same function to each of those different chunks, and then we would have to stitch them back together. And this is all done in one quick command here. Okay. I should have given you guys some kind of exercise to kind of create this table on your own without using dplyr first, and then you would have realized how you can appreciate how much work this saves you. Okay, so here this is all that summarize is doing. Okay, and it stitches it all back together for us. Okay, so here if I applied group by city, we're going to get 3 values for mean. Here if I group by size, we're going to get 2 values for mean. Okay, and so you can easily change the unit, observational unit here. So if we group by size, it works out this way. Okay, and so now we have 2 groups, one for large and one for small, and it automatically filters through in all of this. Okay, so this is incredibly useful function for us. Okay, if you want to get rid of your groups, you can do ungroup. All right. Okay, so here's kind of a thing that we can do. All right, so here's just some information on the number of cases of some kind of disease in different years at different countries here. Okay, so we can group by country and then further group by year. Okay, so we've so this is going to produce a total of 6 different groups here. So we've got 3 countries in 2 years. Okay, we can group by country and group by year. Okay, and then we can summarize by just adding up the number of cases. Okay, and so it says when you added up the number of cases in Afghanistan 99, you have 2. Okay, add up the number of cases in Afghanistan 2000, you have 2. Add up the number of cases in Brazil in 99, you have 4. Things like that. Okay, so summarize. So because when we did group by country and year, it's going to have 6 different groups there. Our summary table here is going to have 6 different rows here. Okay, you can further apply a summarize function here. Okay, and basically it's going to stop looking at the year, and because we said group by country and then by year, there's an additional hierarchy in our grouping mechanism, okay? So if we further run group by, it's going to say, okay, here's a table, and within this table there are 3 groups, and those are country because we initially grouped by country and then by year. And so we can further summarize on country and ask for the, to sum up the cases, and it does that, 4, 8, and 12. Okay, and so there's this, with group by, you can create a hierarchy of groupings, okay? And then you can summarize first on the first level of groups, and then if you want to further summarize, you can further summarize on that, and it goes that. And then if we applied summarize here, it's going to take these 3 rows and sum it down to just 1. Okay. And again, I can't stress how much energy this package has saved in terms of extracting useful information out of our data. Okay. You know, last year's, or this past year's Data Fest winners, they or one, you know, there were 3 winning teams. Okay, one of the winning teams heavily used Applier to get the insights that they were looking for. Okay, in terms of summarizing the things. Yes.
Do all functions that would operate on the whole data structure break it up by group, or is it just the property of summarize that you're recognizing?
Okay, so your question is, so
like summarize, if there were no groups, summarize would operate on the whole data structure.
right. So if no groups were applied, it would take this whole thing and summarize it just down to 1 value.
Is summarize unique in that it recognizes whether there are groups and does it group by group, or do lots of functions do that?
It's just summarize, yeah. So group by and summarize are intended to be used together, because these are both summarize and group by. These are both functions that only exist inside Applier, and so you know, well, you can use summarize without using group by, okay? But if you do group by, I'm just trying to think when we can use group by without. Yeah, it doesn't really make sense to use group by without using kind of summarize, okay? Because all it does is it just tells R that there's kind of these groups that exist, but then if you're not going to do anything with the groups, then, you know, it would be like me assigning you guys to groups and then not assigning a group project or something like that, right? Like, there's just no point in assigning groups if you're not going to do anything with the groups, okay? And really, the reason why we use groups is to kind of reduce the amount of things we have to look at, right? So, like, you know, if a class assigns a group project, it's because it's a large part of it. Okay. Well, one reason is to force you guys to work together and stuff, but another reason is usually the teacher doesn't want to have to look at 60 different projects, but, you know, maybe can look at 15. And the hope is that because 4 people worked on it together, it will be a better project, okay? You know, there's arguments as to whether group projects in school are a good thing or bad thing. Everything in the work world is a group project, though, so if you hate group projects in school, you know, just prepared for group projects in the work world, okay? All right, so anyway, this is, yeah, here's the hierarchy of information, and you know, grouping does it this way. Okay. All right, so to recap, we extract variables and certain observations using select and filter. We can sort them using arrange or arrange them. We can use make new variables using mutate, and we can group observations and kind of get each group's summary using group by and summarize. Okay. Maybe like, do I need to convince you that this is totally awesome? Let me pull up a few of the things. Not that one. So filter, let's see, arrange, select. So these are just some of the things that we did. Oh, there's a command called unique, or I'm sorry, distinct, and this will pull out unique rows. Okay, so this is something useful. So on the data set flights, I can say give me the unique tail numbers. Okay, and we're going to say distinct, and from flights select the tail numbers, and it'll tell me that there's 4,044 tail numbers here. Okay, and or give me the distinct set of flights, origins and destinations, and this is every origin destination combination that is unique or distinct inside the data set. Okay, let me just see if there's anything else. Sample n. Oh, okay, and then if you want to do some random sampling, you can do sample underscore n or sample underscore fraction to select 10% or 1% or just 10 different rows. Okay. All right. Yeah, I think. Okay, I'll post this this file up. This is just something I took from kind of Hadley Wickham's help files and worked through them a little bit. Okay. Whoops. Display driver. Do you guys get this error a lot? I get this like all the time. Oh yeah, something did happen. Look how tiny my my mouse cursor is. Oh yeah, wait. Something just happened up here? Yeah. Okay, hang on. Give me a second. Was it always this illegible, or did it just get worse? It's the same? Nobody's told me anything? You guys have been able to see the screen or no? Okay, all right. It's okay? It's legible? All right, I apologize. All right. Okay, and then the last topic here, also part of dplyr is joining data sets, okay? And so we have a few things. You had like column bind, C bind, and row bind, and things like that. You have similar functions in dplyr. Okay, you've got bind underscore columns, bind underscore rows. Okay, and that just kind of glues them together, either row-wise or column-wise. Okay, bind columns and bind rows. Okay, and then we also have kind of these relational database kind of borrowed from that. We have union. Okay, which I think makes sense here. Okay, it looks at what's common between y and z, and creates the union. Okay, or the intersection. What is common between y and z, and returns just the intersection there. Okay. There is a set difference, which is basically the opposite of intersection. Okay, so intersection tells you what's in common between y and z, and then set diff tells you what's not common between y and z. So it's basically the union minus the intersection. Okay, and then we have left join and right join. So here, I think these join functions are more useful. Okay, and these all exist only in dplyr. Okay. Well, there are join functions and merge functions that exist outside of dplyr, but here we're just looking at the ones that exist inside dplyr here. All right, and so here, you've got a table of songs, and then you've got a table of artists, okay? And here, this is kind of like a lookup table. We're going to say, take the thing songs, the table songs, take the table artists, and then create a lookup and join them by matching the column's name. Okay, and so you got to have a column that's common between these two things in order for them to join up. Okay, and so here it looks up across the universe, John, and plays guitar. Come together. The name again, the name is John, and then when we look it up in the artist table, we've got guitar, we've got hello, goodbye, and Peggy Sue, and we couldn't find Buddy inside artists, and so we get a missing value here. Okay, so left join will preserve everything on the left table, meaning the first table, the songs table. Okay, and that's basically what we said. All right. So again, here we've added a few more things to the artists, the second artists table. Okay, and here because now we have multiple Johns, and so we're going to say, you know, match it on first and last. Okay, so it's going to find John Lennon, matches it here, and outputs it here. Okay, and left join again keeps everything in the first table that you give it. Okay, inner join will look at, it's kind of like the intersection here. It's going to look at the songs table. It's going to look at both tables, songs and artists, and then it's going to say, okay, what is common between songs and artists, and it's only going to return those where it has complete matches. Okay, so it basically drops out this one because in we couldn't find the match for Buddy Holly over here, and so because we're asking for an inner join, it's going to drop that out. The semi-join is even more restrictive in that it's only going to take the rows and the columns. So over here, when we did the inner join, it takes these and it tacks on the column from over here in artists, and over here it's only going to only from the artists column, it's only going to kind of return back the name here. Okay. The anti-join is kind of like the set difference, you know, what doesn't exist in between songs and artists. Okay, give me back what is in songs that doesn't exist in artists here. Okay, and then so we have all of this kind of chopped up and summarized here. Okay. All right, and then all right, this is from Garrett's things. He says you can go to the cheat sheets, okay, which I'll link. Okay, but we can go there also. The cheat sheets you should all print out and have glued or tacked near your computer. Okay, so the R Markdown cheat sheet is great, and then where is our data wrangling cheat sheet? Okay, here it is. Oops. Let's see. Okay, so this is everything here. All right. Okay. All right, and then he plugs data camp. You know, Garrett works for Data Camp, so he plugs his company Data Camp in the books that he wrote. but I do have to say this is a very useful tutorial that he's created for TidyR and Applier. Okay, and so I'll create some exercises for you guys to work through, and I'll probably make that part of the third homework assignment. Okay, and are there any questions? Okay, so yeah, I think the best way you'll get a handle on this is by giving you guys some homework to kind of exercise it. All right. Okay. Well, we'll finish just a few minutes early today, and we'll see you guys on Wednesday.